Welcome back. Today, I would like to talk about one more interesting Python end-to-end project. Before diving into any of the details, like always, I want to give a quick recap of what we have covered in the past, and that can set the ground for us to dive and move forward. We have uncovered some interesting projects around data visualization, around logistic regression. We did talk about decision trees and random forest, which is an extension of decision trees. Now, I want to cover the infamous XGBoost methodology today. And then I also want to leverage some insights such as how the accuracy is going to significantly improve XGBoost, a bagging methodology versus a random forest algorithm or any other algorithms that we talked about in the past. So without any further delay, let's dive into this fun exercise on XGBoost. I want to start with this particular data set that I have researched on. I do think this is going to be very interesting and intriguing to anybody who's trying to understand the social behavior. The variable I want to predict or understand in this exercise is how the emotional well-being can be impacted with social media engagement. While I want to leverage some of the key information in this data set, I do want to drop a couple of disclaimers. All of the data that is being computed and analyzed today in this exercise is probably only to understand the model and understand some of the techniques that we want to cover. In this context, XGBoost, I would not leverage any of this information to give a global insight or try and talk about a particular social media platform, because this data is not representative of a global scenario. And more importantly, this is more of a fun exercise. And so there are no conclusions, but only insights that are specifically and very particularly based off this data set that we are looking at. Okay, so let's dive deeper into this data set. It is called the social media usage and emotional well-being data set from Kaggle. I am going to drop a link of the data set for you to do some exercises in the future and play around with this information. Okay, so as always, I would like to open a new notebook and see where we are headed with this XGBoost methodology. So I'm going to quickly label this infamous methodology. Okay, so we got this. I'm going to quickly run this snippet of code because we need the path that we are going to leverage in this exercise and dive into some of the core concepts of XGBoost. Okay, we have 3 CSV files that is under this Kaggle dataset. I am going to, interestingly, they have both test and train datasets here. I am going to leverage both of them. In fact, I want to combine both training and test datasets and carve out my own training and test sample sets while I train the XGBoost algorithm. So let's start with some of the basic import relevant libraries. Let's start with that. Import pandas as PD, import numpy as np, import mat. I probably don't think we are going to use any visualization today, so I'm going to skip that piece. sklearn model selection, this is kind of a must. Import train test split. We do need some of the evaluation criteria to understand the model performance. So we are going to get sklearn metrics. We are importing root mean, I think it's called mean squared error, then mean absolute error, and R2 score. So we need those. We also want to get XGBoost as XGB, let's call that. We want to import the random forest for our comparison in the towards the end of this exercise. So let's bring that in as well. So from sklearn ensemble, import random forest regressor. That's what I'm going to use today. I think that's pretty much all the libraries we need at this point. We can always come back and fetch more if we need. So I'm going to define the training data set as pd.read_csv. Let's get that training data set here. And very similarly, I want to get the test data set as well and have the test data set. combine the data sets. So I'm going to carve out my own test and sample while I build the XGBoost algorithm. So I'm going to combine the data sets, then replace the null values. And I have one separate steps for categorical and numerical variables. So that's going to be the next step. Then identify, actually separate categorical and numerical variables and enable label encoding for categorical variables, which makes it computationally very easy, and the model can understand these categorical variables much, much better. Okay, so that's an important step. After that, I want to define X and Y variables, then go ahead and train the model, predict the model on test sample, and then we would finally have the evaluation metrics to measure the accuracy and evaluate if we want to move forward with the model or not. I do have a final step. I want to compare the performance with random forest methodology. This is kind of a benchmarking technique to help understand how XGBoost, a bagging algorithm, is much, much more accurate or has higher performance. Okay, so now that we have all the steps laid out, let's just quickly, let me as well number these steps. So number 2 is combine the data sets. 3 is replace the data sets, the null values with the relevant values, mean in case of numerical and an arbitrary value in case of categorical variables. So we have around 9 steps in total. We could add more if needed, if we have the need for it. So for combining the data set, we're going to use a simple function called pd.concat and df underscore train, df underscore test, ignore index is equal to true. This is a quick step to understand how the data type, the new data type is. So I'm going to run that quick validation here. I have done that. Okay, we have the new data set, and it does combine both test and sample, test and train. So we're good to go. Now we want to replace the null values. This is different. I want first tackle the numerical variables. We got something interesting in here. There's you could either identify all those numerical variables one after the other and replace them, replace the null values with mean in this case, or universally you can change what the numerical variables within the data set. Imagine you have 10, 20, 30, 40 variables in your data set, and you want to do those changes universally and not get into nitty-gritty details. This is a fun way to do it. For call in df select d types include equal to number columns. For this, the d type in numbers, we are going to implement this change. So we're going to say df calls, all those columns, we're going to change them with fill na is our function in here. We are identifying those null values and changing them with df call mean. Okay, that should be all set. So let me quickly check the syntax. For columns in df select d types include all those variables that are of numerical data type. We are going to implement fill null values with the mean. After those changes, I do want to see if that works. So I'm going to say okay, so the null values all replaced. How I think the describe function will help me get those values. More interesting way to do this. Describe. Okay, so if there are null values, we would have seen here. So there are no null values. So the numerical values are being replaced. Okay, that's pretty good. And now let's dive into the next step. We do want to take care of the categorical variables real quick here. The categorical variables, what we are going to do is we're going to replace this value to, when it's string type, we are going to replace it with unknown. See if this works real quick. Perfect, we got that covered. Now let's go to separate the categorical variables. So I am going to call out the categorical variables and define them. So what are the categorical variables here? Let me get a list of all these categorical variables. Age, gender, and platform. So I'm going to get that. Age, gender, and platform. We got that intact. Now we are going to do the same thing for numerical variables and bring them in. So daily usage time is going to be my first variable here. Post per day, likes received per day. And then we have comments received per day as well. Messages sent per day could also be used. Okay. I'm going to bring this to a new row so we have all that clear to analyze. Comments received per day, messages sent per day. And then we have the y variable. So we'll come to the y variable. So these are the numerical variables we have. And I do want to take care of, let's take care of the dominant emotion, which is the y variable I want to predict. So I'm going to say, I'm going to keep that separate. I'm not going to bring this into this, into the x variables. I'm going to keep that very separate. I'm going to tackle that in a very different way. And now what do I have? That's pretty much we need. So we have the x variables, we have the categorical variables and numerical variables separated. Now we want to identify, we want to do the one hot, no, label encoding to tackle the categorical variables effectively. Let's do that. So encoding, label encoder is equal to, okay. Now, once we initiate the label encoder for all categorical variables, let's just call this initiate, and then we have for feature in X categorical. That is the only case we need to worry about it. We are going to say X categorical feature is equal to label encoder. This is what this is one more library we need to import. Label encoder dot fit transform X categorical feature. This should take care of the label encoder. And now I want to print the, let's run that real quick. Okay, so the categorical variables are taken care of. Now we have all the details we need. We have changed the categorical variables. Now let's define the x and y variables clearly. So we have x variable defined as df. We do want to concatenate, very similar to what we have done in the past. X is equal to x categorical concat pd dot concat x categorical comma x numerical. Okay, and we would say ignore index is equal to true. That's probably what we need here. Okay, so we have that now. Yeah, let's run that real quick. So we have the x variables defined. X final, let's call that X final. Okay, so it looks like the X variables are defined. Now let's identify. We have combined the X variables, both categorical, combine categorical and numerical variables. So X variables in this context. So we did that. Now let's go ahead and define what the Y variable is. So we already got the X variable set up. Let's define the Y variable. The Y variable is, in this context, I want to get the dominant emotion is the Y variable. However, I am going to replace the dominant emotion variable into something different, because this is more of in the context of a string. This is a string data type at this point. I want to change that into a score. So let's take a look at that. Let's take a look at the this particular variable, right? Dominant emotion. Let's rerun this variable. Okay, so this particular variable, I want to replace it with or map the string values, or replace the emotion, which is in the form of a phrase today, to a score where the model can interpret better. So I am going to define map selection, let's say map sentiment. I'm going to call that map sentiment, and I'm going to define each one of these values. We have happiness that I can define it to as a for a value of 5 to start with, and then I have anxiety that I want to define it as number 3. There's boredom. I want to assign it to number 2, or a score of 2, and there's neutral score, neutral as one of the emotion, and for the neutral emotion I'm going to assign 0, which kind of makes sense. Then I want to assign sadness to -2, and there is the final data set, which is anger. I'm going to assign that to -5, very similar to or analogous to happiness. Okay, so that's done. After defining these or assigning scores to each one of these emotions in the data set, I am going to simply change or create a new column called sentiment scores. Sentiment scores. And for this particular column, I want to simply map to the dominant emotion. That's the column I'm trying to make a change. Map sentiment. It's mapping to make it more clear. Mapping sentiment. So let's try and see how that's going to change our data set. So we have mapped the emotions, and now we are going to completely create a new column that is going to help us understand these different emotions in the form of a score instead of a string that our model can understand better. Okay, so we have created scores against each one of these emotions: happiness to 5, anger to -5, neutral to 0, anxiety to 3, boredom to 2, and sadness to -2. So that's great. It's working as expected. Now let's get to the model. We have defined the Y variable. We have defined the X variable. Let's rerun this piece one more time. Okay, and now let's train the model, or I think we missed one step. we got to split the data set into test and train. So we have 10 steps in total. So the step 6 is going to be split the data sets. Okay. Let's finish the rest of the steps in this model building exercise. We want to split the test and train samples. X test, Y train, Y test. Train, test, split. We want to identify some of the parameters here, like the test size will determine what's the ratio of training and testing sample set. So we are initializing the training sample set to be 80% and test is the rest, 20%. Random state, in this case, is 42. That is for reproducibility. In case we rerun the whole process all over again, we don't want to see completely new values. And this random state is going to help us standardize the runs and the output of the model. Now let's jump to the model step. We are going to select XGBoost regressive for today. We have to select some of the hyperparameters like squared error is the training method. Then we have a couple of other hyperparameters we want to mention in this step. Do that. Okay, so we're going to move that. We have the n estimator, which is more around the number of iterations you want to run. This is completely based on the computational power, number of iterations, and also a way to improve the accuracy of the model. Higher, sometimes more the number of runs. Estimators could mean more accuracy, but it's very much dependent on the algorithm and the number of variables, so many other factors. It's more around the hyperparameter tuning in this case. We do have to specify the learning rate, which is unique to XGBoost model here, which was not part of the random forest algorithm that we looked at in the past. So max depth is another hyperparameter we need to specify. Going to initialize it to 3. You can certainly come back and change it as needed. And the last one will be random state, and I'm going to set that to 42, arbitrary number, and close the model step. Now let's call out the model fit, X train, Y train. So we have all of that intact. We're going to test the prediction of the model against the test sample. Model predict, X test. That's going to take care of the model prediction. Now we want to set up some evaluation criteria to make sure our model accuracy, validate the model accuracy. So we have the root mean square error, RMSE, that we imported from scikit-learn metrics. So we're going to get the means squared error, Y test, Y predict, squared is equal to false. That's going to give us the root mean squared error. Print root mean square error RMSE. That's going to give us, it's going to print the RMSE for us. We also have a second criteria we can test on, which is the mean absolute error. We get that mean absolute error call here, mean absolute error. We don't need the squared parameter in here. We have the R2 score. To get the accuracy of the model. So we're going to call that out. Again, it's going to be exact same syntax as mean absolute error above. I'm going to get the print. Just going to copy that here and change this to mean absolute error. Uh, Accuracy score, I'm going to say that. Accuracy score, and I'm going to call out R2 score here. So that's pretty good. And now I do want to bring in one extra step of benchmarking the whole model with random forest algorithm that we developed last time. Random forest regressor. In random forest regressor, we don't really need a training method here. We have the n estimators as a common hyperparameter and random. That's pretty much what we need here. So we're going to do the same and rerun the evaluation model here to get and compare the accuracy between the random forest and also against the XGBoost methodology. So we got that intact. Okay, let's try and run this and see how the accuracy of the model is. So it looks like it's giving us the results that we need. We have 88% accuracy score, 74% mean absolute error, which is pretty good. So far, we're tracking good. Let's run the benchmarking model to see and compare the difference between the XGBoost and random forest in this context. So we're going to rerun the whole model training step till the end of the evaluation and the accuracy scores. When we rerun that step, let's see, we have a 43% accuracy score. That's a significant improvement in the accuracy score. XGBoost has 88% accuracy score, so twice the accuracy. So this is why the infamous XGBoost methodology is so popular, and we can rerun the step to see, to understand and see the difference between the accuracy. Okay, so we're going to rerun the whole process with the XGBoost methodology, and okay, rerun the whole process and see the accuracy score is 88.5% versus random forest in this context was only giving us 43% accuracy score. So that's why I think XGBoost methodology is quite infamous and proven very efficient in a lot of business applications. Okay, that's all for today, and we'll catch up again soon. Stay tuned.